Okay, shall we get started? So welcome everybody to Haystack Live. This is our regular meetup on search and relevance. And we run these about every 4 or 5 weeks. We are looking for speakers, so if you have a talk or you know someone who might be able to give a talk on any aspect of search and relevance, then do let us know and encourage them to apply via the Haystack website. We're recording this meetup, so it'll be available on OpenSource Connections YouTube channel later. I will also say firstly an advance thank you to our speaker Bob today, who's going to be telling us all about the Weaviate open source search engine, which handles vector search, which is obviously very new and exciting and where search is going. Little plug as well, if you're interested in vector search, at the Berlin Buzzwords Conference in mid-June, our very own Max Irwin will be joining Dimitri Khan on a Ask Me Anything session about vector search. So hopefully you'll be interested to come along to that. At the end of Bob's talk, we will have a chance for Q&A. So if you have a question, you can drop it into the Zoom chat. I'll then ask it on your behalf. I may ask you to clarify points if I can't understand the question from the text. During the talk, if you wouldn't mind keeping your microphone muted, if we do get any background noise, I may have to nip in and mute it for you. And that's about it. I will hand over now to Bob, who's going to give our talk. Also, just my colleague Max Irwin is also here as a co-host. So looking forward to this, and thanks for coming. Bob, let me just make you a spotlight, and then you should be able to share your screen and get started whenever you're ready.
I can. So thank you very much, first of all, for having me. That's super cool. So thank you. So let me share my screen. Here we go. Does this work? Can everybody see it? I'm just double checking. It's visible, right? My screen. I'm gonna.
It is.
Yes. Okay, thank you. That's very helpful. Yeah. So what I'm gonna do is I'm gonna say a few words about or show you a few slides to just give you a little bit of context to why what Weaviate is and why we think it adds value to search, or why it's relevant. I'm also going to show you how we try to aim to solve the problem that I'm going to introduce, and then of course I'm going to dive into a demo, because I would love to show you, of course, how that works in action. And then at the end I will also give you some pointers where you can go and where you can find the software, and how you can where you can find the documentation. I'll share what you can find on GitHub and those kind of things. So if you're interested or if you're curious, then you can start working with Weaviate yourself. So the question is why. So why is sometimes people ask me the question, why is this interesting? Why do we need another search engine? Because if we have great search engines in the world, and which is true, and the easiest way to actually show this problem is with the following data object. So here you see a data object, a data representation of a wine, and this wine has a description that it goes well with fish. The problem now is if we want to retrieve this data object, and we do that with a air quotes traditional search engine, we often work with keyword matching and those kind of things. So it's going to be more difficult to actually match the results or the data objects to the query. And what the vector search engine brings to the table is that if we have a similar question, that it's actually doing a similarity search between the query and the results. So it looks for something rather in the vicinity than it tries to make an exact or fuzzy match. And then we can actually find the result, because in the vector space, something we'll also be talking about, we see that there's a relation between, for example, fish and seafood and Chardonnay and wine and those kind of solutions. So what we target and what we aim for is that huge pile or ever-growing pile of unstructured data. We don't only do that for text, we also do it for images and those kind of things, but that's really what we target and what we aim to solve with Weaviate. And what I always like to say and give as an example, a great example of a vector search engine is actually Google search, right? So here you see a similar question. And so what color of wine is Chardonnay? Well, it's white wine. So the thing of having the abstract query and getting finding this node in this case in their knowledge graph, that's one thing, because that's of course coming from the machine learning models and the vector representations that the models create. So we within Weaviate happily use these models, and we're great for the whole ecosystem of models that's growing. But what we are interested in is more like, so how can we enable you to do these kind of things with your own data? And how can you do it so fast? And how can you scale it so far? So that is the problem that we aim to solve with Weaviate. So we want to make these models available through a very simple API endpoint, and then in a way that you can use it like you would use any other search engine, or for that matter, any other database. So that's our focus, and that's the problem that we aim to solve. And we are also creating a modular ecosystem around this. So, and you will see that in a bit as well. But that's our focus, and that's the core problem that we aim to solve. And what I sometimes like to give as an example, just as a way of understanding, or as a metaphor, is that I often say, like, so what Solr or Elasticsearch have been doing with Lucene, we try to do with Weaviate with vector search or nearest neighbor libraries. And we can, if you want to know more about that, we can go into questions, we can go into the nitty gritty. But what we actually see is that the inverted search indexes is indexed searches is not necessarily suited for these kinds of searches, especially in the future if you want to scale it. So that's why we believe that there is a new opportunity to introduce a new type of search engine. So that's the reason for why we for our existence. So as I just mentioned that, so we want you to be able to do this with your own data, rather than only having to rely on services that are doing that with public data. And these 4 points that you see are very important for us. We want it to be easy. So we strongly believe in a developer UX. So we try to make it as easy as possible for people to use. And if you disagree on how we do it, then we would love to, of course, hear from you. Our focus on doing stuff fast. So we're constantly working on improving these ANN libraries. We also, within Weaviate, we really want to offer full CRUD support, so that you can create, read, update, and delete any data object that you have, including the vector representation. Secure, well, what we mean with secure is as so much as that you can run Weaviate everywhere. So Weaviate is just containerized. Yes, we offer it as a SaaS, but you can also run it on your own, wherever you want to run it. And of course, we focus on scalability. So scalability is something we focus on in 2 ways. So you can look at that from a horizontal perspective and a vertical perspective. What we mean with the vertical perspective here is, of course, improving these ANN libraries. If you really like to dig into the nitty-gritty details of Weaviate, you can see on GitHub actually that we go all the way into assembly to try to optimize the ANN search functionalities. And horizontally, of course, we talk about sharding and horizontal scalability. Currently, we're working on that. So if you dig into our architecture, you will actually see all the signs of where we're going. And we are expecting to release the first horizontal scalable version of Weaviate in the Q3 of this year. Depends a little bit on the use case that you have if you need it, but currently we have 0 use cases where we really need to scale horizontally. We once got a request in for dealing with social media data that's coming in real time, then that's really needed. But most cases can be solved already out of the box with the vertical scalability. And that comes, and it's something that if you start to experiment with these kinds of search engines, you will see that actually creating and adding value is actually something that's, you don't need a lot of data to do that. So a lot of insights are actually coming from the models. So that's what we mean with Weaviate being cloud native. So it's just as you will see in the documentation. So for development, it just comes with as Docker Compose files, or we have Helm charts and to run Weaviate as well. It's modular. This is something that we believe to be very important. So we don't stop with Weaviate at just having the vector representation so that you can store the vector, but we also have, we're creating all these modules that Weaviate can do the vectorization for you, or that you can add features to Weaviate. We try to be as real time as possible. So my colleague Kei Chen wrote an article that we were able to already get up to 50 milliseconds retrieval, and that's just that in the future that will go up, down. Sorry, that number will go down. And we are a vector search engine, so, or a vector database, whatever you like, or if you say, well, it's a flavor of databases. We really focus at the heart at these vector representations. And last but not least, important to mention, so we have a graph-like data model, and when I give you the demo, you'll see this, where you can represent your data in RDF-like structure. Why RDF-like? This does not mean that we walk away from certain standards or something, but the question is like, how can we leverage GraphQL as much as possible and make it as easy as possible for developers to use it? And hopefully when you see the syntax that we came up with and how we structure that, hopefully you agree with our approach there. This means that Weaviate completely supports GraphQL. It's not a different flavor of GraphQL or anything. So if GraphQL offers it, we can use it as well. So that means that basically any library that you can use in GraphQL, you can use for Weaviate as well. Then one more thing about a little bit more about like by vector search. I already said something about it, but to go one step deeper, I mean, we can go down the rabbit hole, but I'm for this presentation, I'm not going to do that. But the problem that we aim to solve is that we say, like, if you think about, for example, a graph representation of your data, why, instead of trying to find the exact node in the graph or make relations to that node, why not try to take the approach of trying to find it in the vicinity? So here you see that based on that Covey-Run 2005 Chardonnay, it will, depending on the model that you use, but the point is that it's somewhere represented in that vector space near to where the words of the query lie, or the sentences of the query line. And that's what our core focus is. And again, when I give you the demo, hopefully you'll see what the added value is of that. As I mentioned before, Google is also a vector search engine. So it's like, the the type of interaction and how that works. And our focus is really doing that on scalability and speed, and allowing you to use as many models as you like. What's important here as well, so when we enter the API level, so that's also something you're very used to, of course, from Solr or Elasticsearch or what have you. And because we want, of course, enable you to build whatever you want to build with it. So this image represents basically this modular structure that we have. So at the heart, here you see that's the Weaviate database, or the Weaviate, the core, which really focuses on vector storage and search first. And then there are three important core features in Weaviate. That is the object storage. So you cannot only represent the data, you can the vector representation of the data, you can also store the data object itself in Weaviate. We have all kinds of data types and that you can use to store the data. You can do the vector search, so you can search based on vector and similarity, but you can also do more traditional filtering. So for example, if you would say, well, I have news articles with dates attached to them, with the date data type, then you could say, okay, I want to do a vector search, but I want to do that based on all articles that are written in November last year, for example, or those kind of things. Or if you search to do a vector search or similarity search to product descriptions, then you could say, well, the vector search might be show me everything related to, I don't know, to wine. And then the filter might be like, but it only should be products that are more expensive than, I don't know, $10 or something. So just traditional filtering. and vector search. So you can mix them together in Weaviate. And then in that outer circle, we have all this ever-growing these ever-growing modules out of the box that you just can use. So, and you can combine them if you like. So some ones can be combined. So for example, semantic search and question answering can be combined, or you can throw image vectorization in. Of course, you have image search, and you can also add any other data type you like. So for example, we saw somebody, this is a little bit far out, but somebody was looking at vectorization of DNA. So then one of DNA string vectorization. So then you could have a module in theory that you just feed it a DNA string, and then Weaviate stores that for you. You can also create them yourself. So in the documentation, it's explained how that works. If you say, well, this is all nice and fun, but I don't want that. I just want to have a vector database where I can store my vector, and I want to search through them. You can do that as well. But again, going back to the developer UX, we really want to, offer as much as we can. And if you're missing something, then of course we would like to hear that from you as well. Well, last thing about this. So what's interesting to see, the reason I put this slide in, you can see that this is a little bit different slide from a visual perspective. The reason why I added this specific slide is like, one of the questions that I often get besides the tech question is like, okay, so what can I do with vector search, right? So where do we see a lot of added value? And these are the industries where we're doing a lot of work in, and where we see a lot of added value, mostly in the form of automatic classification or semantic search or similarity search. So this is just a bunch of industries that we're working in. And if you want to learn more about that, then just let me know, and I can explain to you a little bit more in depth how we use Weaviate there. Because of course, where we currently are, when it comes to these new types of search engines, is actually like, showing to the world what we believe that you can do and that you can uniquely solve with it. So that's the reason why I added this, which brings me to the demo. So first things first. So there are a few ways that I like to start from the perspective of our documentation. If you Google for Weaviate, you can miss it. You get to the developer section, or if you go to our GitHub, then you can't miss it, right? So it's like you get the documentation links, and then you add up in the documentation. Of course, very important for us, because this is the starting point for every developer, how they start working with Weaviate. And as you can see, it's like the ANN plugins that we have, the modules that I talked about that we have, the clients that we have, the RESTful API references, the GraphQL references, and some additional materials. Weaviate has 3 core root functions: get, aggregate, and explore. And for my demo, I'm going to use get, because that's the most used function. Aggregate is, for example, show me how many documents I have, or meta information. And exploring is really used to purely search to the vector space. And of course, we have additional filters and properties. Sometimes certain modules add filters as well. So then you find the documentations for these filters inside the modules. If you try Weaviate out and you have any suggestions what we can do with our documentation, how we can improve it, then please do reach out to us, because that's something that we of course want to learn. If you look in our documentation, you see every, for in this case, GraphQL example is followed by the client libraries that we have. So this GraphQL query is represented in Python like this, or in JavaScript like this. And then we have Go and Java as well. And of course, a very old-fashioned, or well, not old-fashioned, but well, a curl command for whoever wants to use curl to search through the vector space. One additional thing, something that I'm also going to use for my demo. What you will see in our documentation is that all documentation is based on news articles. And the reason we do that is because every query that you see in Weaviate, there's this green bulb here. And then if you say click here, you go to something that we call the Weaviate console, where you can actually try out these queries. So so you can play around with them. So let me give you a quick demo. So I'm going to start not from the perspective of the article, but from the publication. And if I say, well, I want to show, so we have a class structure, which publication, hence it has a capitalized first character, and the property here we have name. So if I run this query, it's a very boring query, because it just says like, okay, show me all the publications that you have in the data set. So these are the results. Now, what we can do is that we can add filters to that. So let me start with using the most simple, straightforward filter that we have. That's limiting. So if I now say limit 1, then it just gives me the first result, which in this case is Fox. But what is nice to show you is that we also have these additional properties. So we can actually ask Weaviate, okay, show me the vector representation of how did you store a publication with the name Fox News. And if I then run this query, then Weaviate actually returns that vector representation, as you can see here. And you can do that for every data object, and the power sits in the fact we believe that Weaviate does that for you. So the moment that you add data, it automatically vectorizes it. So let's go one step back. So now, how can we now put these models to work? Well, we have, for example, semantic search. So one of the things that we can do is we can say, well, let's search for the concept, and then we say, for example, fashion. And what happens if I run this query is that it vectorizes publications about fashion, and it matches that vector representation to whatever result that's the most closely related in this vector space. So if I now run this query, then I see, well, it returns Vogue. And the important thing here to mention is that it's like there's no underlying connection, there's no underlying way of making relations between the magazine Vogue and fashion. It's purely and alone coming from these machine learning models. And we not only do that for these simple strings, but we can go even a step further. So let me go a little bit further. So let's now look at the graph from the perspective of the articles. I'm going to get back, by the way, to the publication, because I want to show you one more thing about this. Same query as we did before, but now we do it from the perspective of the article. So you see like a wide variety of topics. We can also say, well, show me the summary. Of course, we've used the summary to also to index, tell Weaviate how to index these articles. So what we now can do is we can do something similar as that we did before. So let's stick with semantic search. So I can say, for example, show me everything about housing prices. And I want you to do that with a certainty of at least 70%. And what we mean with certainty is the distance in this case in the space. The reason we chose certainty is because for people who are not machine learning or data scientists, we learned that by testing out, it was a little bit more intuitive to use the word certainty. And what I can say as an additional property to show actually the certainty in the result. So simple query. Now run this query, and here you see like housing prices in the result are booming. Well, fair enough. It says house and prices, but if we look at the second result already, we see that the certainty is a little bit lower. But you can say now you can move into an Italian house for just $1,200, and there you see that housing and price is not in there. And we can go really far with this. So we can say, like, for example, in Scandinavia. So housing prices in Scandinavia. And then if I run this query, you see here the Swedish house on the market, etc., etc. Where of course Sweden is in Scandinavia. So this is where you see practically how that matching of the data objects works. And one of the modules that we've added here as well is the Q&A module. So we can go even a step further and say, okay, let's look at this from the perspective of Q&A. So one of the things that we can do is that we can say, well, we can ask a question. Oh, apologies, question. So let's say I'm based I'm in the Netherlands, so I'm in Europe. So I can say like, who is the king of the Netherlands? We can tell Weaviate in which properties that it needs to search. Important to bear in mind, the answer needs, of course, to be in the data that you added, because if it's not in the data that you've added, then of course you can't find the answer. And then we can use the additional features to actually represent this result. So we can say answer, and then we can say result. So this is a very simple query that now we go one step further. We're not only doing semantic search on finding these data objects, but we're also going to look inside the data objects to find the result. And now if I run this query again, it says like, oh, let me say limit 1, because we only look at answers in the first result. So it says like King Willem-Alexander, which is correct because I'm Dutch, so I know whom our king is. So this is the correct answer. But now the cool thing is that you can start to mix in these GraphQL references. So we can say, well, so in which article did you find this answer? So we can add the title, and then we can say, for example, which is, by the way, true. This is indeed what they did, but well. And then we can say, for example, we can say like in publication, and then we can say on publication, what's the name of in which publication this was presented. So you see that now we both have the answer in our result based on the query, and we see that this is coming from the publication, The Economist, where we just made a graph relation. What's nice to show is, like, for example, you can go pretty far with this. So you can say, for example, another one is like what COVID vaccine is available. So what COVID vaccine is available? That's a query that we can ask. So we keep the rest here the same. So here you see also coming from the Economist, and then you see Pfizer, but we could also say like what COVID vaccine is available besides in this case Pfizer. So if I now run this query, it says AstraZeneca. And if we're now curious like where that it's found this, we can even go further. So we can say that, well, we want the start position and the end position. And of course we need the summary to see where it's coming from. So now we run it again, and it says like, well, the answer to this question is this start position and this end position in this article from The Economist, etc., etc., etc. One more thing that I want to show you, or two more things that I want to show you before going back to my presentation, is that, or to my slides, is that I'm going to go one step back. Get publications. So I'm going to take one step back. So I'm going to go back to the publications, because one of the cases that we often see as well is data harmonization. So what you see here, you see we have the New York Times Company, we have the International New York Times, and we have the New York Times itself as data objects. And the problem, of course, is, and if you work with data, you probably know this problem, that it represents the same thing, but it's stored, because of it's written differently, it's stored in different data objects. So one of the things that we have here as well is that we can say, for example, group, it's called group. And then I can say, well, type, I want you to merge nodes together if you can. And then we need to give it a force. What we mean with force is like how big in the vector space need you compress it together. So we can set that relatively low. So we say, for example, like, this is 50. So for example, with 5.05% from the whole vector space. And if we now run this query again, then you see that maybe it's, let me see, close is actually, I think, better to show you. You see that let me see, I'm looking for something else. We have, yeah, it's a live demo. Sorry, let me quickly see what I wanted to show you. So let me set it a little bit higher. So like this. Yeah, so what you see here, sorry, this is what I wanted to show you. So what you see here is that I shouldn't have done a group but merge, because you can see how it merges them together. So what you now see is that it merges these nodes together, such as the New York Times Company, the New York Times, and the International Times are grouped together. And now you could even say, so if you say like, well, but actually, you know, I think that the International New York Times is something else, then you could even say like, well, let's go then lower a little bit the how are we going to merge. And then, you see that I merged a little bit too much. So here you see that the New York Times and the New York Times Company and the New York Times are merged together, but the International New York Times is still a node on its own. So that's an example of things that you can do as well. And if you go to the documentations, there are way more or many more functionalities within Weaviate that you can play around with, coming from the modules, coming from in the filters, something that we didn't talk about at all is classification. So you can have Weaviate automatically make relations in your graph, but I don't want to flood you with information and just show you in a nutshell what Weaviate does. So that was so far my my demo. If you just Google Weaviate documentation, you can't miss it. You'll end up here. If you go through our GitHub page, then don't forget to give us a star. And let's see, what do I have more? No, nothing. I don't have anything more. So this was my presentation, and I'm looking forward to hearing your questions, and I'm also looking forward to trying it out and letting us know what you think. We're like on Slack, Stack Overflow, email, Twitter, whatever you like or prefer to use. That's you can find us there. So thank you very much for listening, and I'm looking forward to hearing your questions.
Bob, thank you so much. That was great. We have got some questions. I'm going to try and run through these and firstly understand them enough to ask them properly. So what do we have? Okay. So Artem asks, is it possible to search in the fields you want, not all the fields at once? So is it possible to vectorize text per field?
Yes and no. So in this specific case, so not no, actually the answer is yes. So one of the things that we have is in Weaviate, I didn't show you this, I was thinking about it, but when you create a schema in Weaviate, so you have to create a schema where you say, okay, this is the class and these are the properties. You can actually tell Weaviate, okay, I want you to vectorize these properties, but not these other properties. So that's something, you have a lot of flexibility in setting it up. And what you can even do is that you can say like, well, I have different vectorizers. So for example, you might have a transformer module, you might have an image vectorizer. So you can say, okay, I want this node to be vectorized based on with the text vectorizer, and I want this class or node to be vectorized with the image vectorizer. And now you can mix data types together. So you can do similarity searches on images, and then go into the text, or start with similarity search on text, and then go into the images, etc. And that's the schema. So when you start a Weaviate, you must define a schema. Some people have super simple schemas, and others have a little bit more complex schemas. And what I can do is I can super quickly share a blog post about that graph schema in the chat window. So here you go, Artem.
Fantastic. Thank you. Okay, so we have another question here. I'm not going to attempt to pronounce your name correctly, I'm afraid, but you'll know who you are. What advantage do you see with Weaviate compared to a couple of other vector search engines? I'm guessing here we've got Milvus and Gina. Yeah, okay, it's a great question. So there are a few answers there. So do you mind if I make it broader, because we see more solutions? So that because then I just address the wider space that's available. So there are a few things that you can do. So at one end, you can go all the way to just building your own software with your own ANN libraries. They're just available. That would compare a little bit like downloading Lucene and building your own search engine, opposed to, for example, Solar or Elastic. If you would have that use case, then great, go for it. That's something you can do as well. So that's what we see on one end. Then we see on the other end, we see some competitors that they only focus on storing the vectors. So you can only search through the vector representations. Probably there are use cases for that as well. Then you see certain solutions that have where we believe that how should I say, so Weaviate is written in Go, and we think we can get certain benefits from that when when it comes to scalability and speed. Some others have taken different approaches to that, and so we think that we
that the users of Weaviate benefit from the perspective of that scalability and the architecture that we've chosen. But last but not least, and that's the most important one that I want to mention, is that what I showed with that modular ecosystem around it. So that we believe, and I'm not gonna lie, that is something that I was very inspired also by how, for example, Elastic is doing that with their XPack and those kind of things. They said like, hey, we actually want to make that available for vector services, so that it becomes really easy to run it out of the box, spin it up, and get working with it. So I think that those 4 answers I gave would, paint a picture about the landscape and our air quotes competition. But people are working on amazing stuff, and I'm glad to see people also enjoying to use Weaviate. So it's so new, so we'll see where it goes. But it's a lot of exciting stuff is happening. But I think that if you make a decision what you want to use, I think you need to answer yourself the question: do I, for whatever reason, want to build it myself? And then I would say, well, good luck. But in theory, you can. The second thing is, like, if you only want to store the vector representations, then that might be a reason to do it, to make the decision. And if you say, no, I'm actually looking for a database that does this, that I can also store my data in it, do faceted search and those kind of things, then we hope that you'll look at Weaviate. And let me quickly share a link about that as well in the chat window. So sorry, long answer, but I hope that
that's great. Yeah, that's position. I think that's positioned quite clearly where you're aiming at. So, so we got another question here. I think this is actually from the demo. Which article field is the near text? Your near text operator there looking at? Scott asks.
So I think if I understand the correct, and if I'm not understanding you correctly, Scott, then just let us scream. But I think you're asking like if I use the near text vector representation, what are we looking at in the data object that represents these articles, like the title, the summary, etc.
Correct. Yeah, that's what I was wondering.
Okay, cool. Yeah. So it looks at how the object is stored, and that is something that's determined in the schema. So what we say, for this specific data set, what we say is like, use the title and the summary of the article to create one vector representation for this data object. So it matches this the vector that comes from the query to all these individual vector representations of these articles. And that is something that you as a developer have control over in the schema. So you can say, okay, I want you to vectorize this, but not that. A very practical example there. Sometimes we see people who use Weaviate for website search, for example. So then they have a data object that's, for example, web page. And then they have content that only contains the words, the language. And then they have, for example, the HTML representation that they store as well, so that they can quickly retrieve that data object and show it to the end user. But of course, they don't want to vectorize the HTML tags. So then they say in the schema, vectorize the text, but not the HTML object, so that they can very quickly represent that search result to the end user without the HTML text cluttering the vectorization of the data object.
Okay, great. Trey asks, how many documents were in your demo collection?
3,500, I think. So something like that. There's an aggregate function to it. So if you start playing around with it, it's aggregate, articles, meta, count. That's the GraphQL query to show that. If you're asking, I'm going to make the assumption you're asking this question based on like, so where could we go? The biggest data set that we work with internally to experiment with are 1 million archive from the scientific platform archive data set, but we have users and customers that use way bigger data sets in Weaviate to search from. One of the things that we believe is that we can always represent a, sorry, with the vectorization, you're paying for that on import time, but you're benefiting from that on query time. So I sent another a blog post from one of my colleagues in the chat window, where you can see how we can get to sub 50 millisecond retrieval rates on huge data sets.
Okay, thanks. Chris Marino asks, have you got any demos where you're indexing the same data into both Weaviate and into a more traditional TF-IDF based engine like Solar or Elasticsearch?
No, we haven't done that. And so we have internal benchmarks, but there's a reason why we're not publishing them. And that is that we hope that somebody from the community will do this. Because if I am going to publish a benchmark about another search engine, then that's kind of, you know, it's like then I'm tasting my own medicine. So I think we hope that somebody from the community will make a comparison. And so and it's difficult to make these comparisons, because if you, for example, have a vector database that only does vectors, now you have a difficult question, right? So because Weaviate stores the vector and the data object. So then you might say, well, this database got my vector out faster than Weaviate. But we also represent that data object. So we also need to look at how the industry or the projects are developing. And I think that at some point we'll get a split where you say, okay, we just have pure vector search, and we have these databases that that use vectors at the core, like, for example, Solar is using or Elasticsearch is using Lucene at the core. And then hopefully somebody will go to the effort of doing benchmarks publicly. But I hope that's a satisfying answer. But that's the reason why we don't publish them, because it would be a little bit weird if we would say something about our own benchmark against other solutions.
Okay, so that's a great there, Chris. There's a job for you, Chris. You can set up a comparative demo for us. So Connor asks, what's the indexing process look like when you did the demo? I mean, is Weaviate generating the vectors itself, or is it storing the vectors that are created by something else?
Yeah, so that's a really good question, and I can interpret that question in two ways. So let me answer both, also for others who would like to know. So the modules that we have, they contain the machine learning models. So the module contains the model, and that is what does the vectorizing for you. The nice thing is that you don't have to do anything. You just I didn't show you the but if you go to the installation guide, you see there's just a few steps that you have to go through. You choose your models and your modules. You do okay. You get a Docker compose file, and you don't have to do anything. Weaviate takes care of everything for you. So that's that's one part of the answer. The second part of the answer is, like, we have customly trained models. We call them contextionaries. We see that they perform very well in classification tasks. But for example, if you use the transformer modules, then the model inside the Weaviate module is just a transformer model. And you can even go as far as you say, like, I have a custom built machine learning model that I want to use within Weaviate to automatically vectorize the data that I'm adding. You can even create your own modules.
Okay. So moving on to our next question. Oh, and by the way, everyone, if you've asked multiple questions, I'm trying to get everyone to get a chance to ask at least one. So I may skip if you've asked more than one question. So Jaco asks, how do you handle language?
That's a metaphysical question.
How do you handle language in Weaviate? So
exactly.
How do you index content in different languages, I guess, is the...
Yes, that's what I meant. So finding concepts in Dutch and in German is totally different from English. Word order, compound words, all that sort of stuff.
Yeah. Do I hear a Dutch?
Yes, you do.
Hello, Dutch guy. Yes.
Yes.
So yeah. So that's our accent, I guess. Yeah. No. Yeah. So that depends on the module that you choose. So sometimes you see these models, machine learning models that are multilingual. sometimes you see these models that are trained specifically for a language. And one of the things that we do is that we see when it comes to transformers, we see that sentence transformers work very well for semantic search. So we make them available for in languages where you need them. You can also train them yourself, whatever you like. We've seen, we have use cases where we work with mixed languages. So then we use a multilingual transformer model. Having that said, a model specifically for a language, yeah, it just works best. That just yields the best results. But you can actually play around with that. So you can even mix different languages inside of Weaviate depending on how you create your schema. So we hope that there's a lot of flexibility to solve your use case if you have mixed lingual data.
Thank you. And then Eric asks, what granularity are the vectors? So he's got content from 2 sentences up to 300-page books. How do you put that in the, can you, if you put that content in the same field, how does that affect search?
That's a really good question. So the we deal with that as well, right? So we have users and customers that, for example, have like long PDFs of, let's say, 300 pages. So now you're like you have a chicken and egg problem, because you could say, well, I can say like this book has this vector representation, but the problem is it of course becomes extremely ambiguous because you're trying to represent the whole book in one vector representation, which of course becomes too ambiguous. So how do we do that? How we solve that in Weaviate? This is the part where the graph part is used. So we can say, for example, we have a data object which is called book that has just the title of the book and maybe a summary of the book to vectorize. And then we can say in the graph we can say has pages, and then we have for every individual page we have a data object, and those have vector representations as well. So now you can have a query, so where you have a book that you say like, okay, in this book, that's just a traditional scalar search for all these pages and do a semantic search or do Q&A in there. Or the other way around, just search for all pages that we have available and show me from what book this result is coming. That is often how that's solved. And now I'm thinking about it, this might actually make a nice blog post to write about, so how you solve this. But this is where we believe that the power of mixing scalar search and the graph-like data model and the vectorization comes in handy, because this is actually how we solve these problems currently. Yeah.
Great. So Max, our very own Max Irwin, asks, when combining filtering with vector similarities, does the filter happen before the approximate nearest neighbor query or after?
That's a very good question. I should know the answer. I think before.
Think before. Okay.
I might.
Nearly stumped you. Well done, Max. Moving on, we've got Connor has a question. Connor, you've had a question already, so I'm just going to skip on to see if Sinan can ask there. So does Weaviate have multiple GPU or TPU support? Yes. Can you support? Yeah.
Yeah, so this is one of the things that we, again, hopefully we believe that this is part of Weaviate. So the Weaviate database runs purely on CPUs. The contextionary modules that we have run purely on CPUs as well, but the transformer modules on GPUs. And actually inside the Docker Compose or the Helm charts, you can just set a Boolean value. Do you want to use GPUs, yes or no? And then Weaviate takes care of it where it's needed.
Clever. Fantastic.
Thank you.
So I'm glad to see we've got people answering their own questions within the chat here. But Paul asks several times, can you tune how certainty calculates the distance?
Yes. Brilliant. You can do that in the configuration of Weaviate. So you can go one step deeper. So there's a configuration YAML file which all these very specific, like how you can tweak the ANN library and those kind of things. I have to admit that of course you can find this in documentation. I don't know this exactly by heart, but you can go as far as tweaking that as well if you like. Yes.
Fantastic. So we're just cycling around now. There's some people asked several questions. So who gets the second question? Let's have a look. Yako, do you need some minimal amount of data to get this going? Do you mean on the language question, Jaco? Is that a separate question?
No, it's a separate question. In general, when you have to train models, you need some kind of minimum amount of data. And you just mentioned the number of news articles was quite small actually, and get these kind of results. So I was just wondering, do I need millions of documents or hundreds to get some stuff out of this?
No, I would advise more than one document, because if you have one, you always get the same answer. But that's one of the things we believe to be very powerful. You don't need a lot of data to do this. So we, for example, have use cases where people use Weaviate to search the product catalogs, and they just store the summary of the article, of the product. So then you have, I don't know, 60K products, which is a relatively small data set, but they get a lot of value from it because the models are actually knowing what to find in the vector space. So the short answer is no, you don't need a lot of data. I would say more than one.
Okay, cool, thanks.
Great. So Artem, your second question. So can Weaviate be used as a graph database?
Yes, it can. The question is like if you want that, right? So we really focus on the vector element and the vectorization. There are great graph databases around. So if you say, okay, I'm going to use Weaviate as a graph database and not going to leverage the whole vector thing, yeah, maybe there's an added value there. But yeah, so in theory, yes, you can. The question is like, if that's something you would like to do. I mean, if you want, then you're more than welcome, of course, to do so. But
so you can, but it's not really what it's for.
Yeah, exactly. You know, you can open a can of beer with a spoon, but it's like, you know, it's like the question is if that's what you want to do, right? So,
fantastic. So we've got another question about incremental indexing. How do you handle that?
I need a little bit more context to this question.
Okay, Kui, are you here? Can you ask your question?
Yep, I'm here. Can you guys hear me?
Yep.
Yes.
Yeah, so I guess the background is from a traditional search engine perspective, right? You usually have incremental indexing running, keep indexing your documents. And for example, in Elasticsearch, you perform, let's say, normalizer on your fields, store them in your search engine. I guess my question is, compared to the vector-based search engine, because the goal is to scale and indexing decent amount of documents, right? So incremental indexing, to me, it's a kind of crucial components compared to just, let's say, the ANN library, let's say Annoy or Face, right? They're mostly in memory. And that's why I'm asking this question. So I do curious, like behind the scenes, in terms of bringing up a distributed search engine for vector similarity search, what's kind of the technology or the strategy you choose to go in the implementation?
Yeah, so this is a really good question, and I'm not going to be able to answer the question in full because it's my colleagues who are working on the deep tech side of Weaviate are working on it. So I shared this link already, but I'm going to share it again. There are two things that I want to highlight to try to answer your question as far as I can. The first thing is that the libraries that you just mentioned, like Annoy and Vice, right? They work in memory. And that's something that Weaviate does not. That's one of the actually added values that we hopefully bring to the table, because that means that your data stays persistent. Really like you would be, the thing that you're used to from any database out there. Bear in mind that we need to do multiple types of indexing, because we don't only do the indexing from the ANN perspective, but also from the just the scalar search perspective. Currently, I believe that our ANN search is so far optimized that it's bottlenecking on the way that the inverted index, I believe that we use is built, and that's now being optimized as well, because there's a lot of trade-offs that you can do how you store that. If you really want to go into the nitty-gritty, then I would like to invite you to join our Slack channel, because then the people who are working on specifically that part of Weaviate can answer that question in lots of detail for you. And I know that they go all the way down to the assembly level solving this problem. So it's a great question. And I'm sorry that I can't go in any deeper in answering it, but that's yeah, that's as much as I can give you now.
Great. So we've got one more question from Max here. Is there any re-ranking you can do in Weaviate? Can you do any kind of learning to rank style re-ranking?
Great question. So currently not, but there's no specific reason for that. So one of the things that we're looking for is use cases. So if you say, hey, actually, I have a specific use case where I want to do a specific type of re-ranking, please let us know, like on GitHub or Slack or whatever, so we can prioritize that and we can actually make that part of the stack. Because what we currently do is that, of course, we get feedback from the community. We also have, we're also business, so we also have customers. So that feedback is something that we're using to make Weaviate better. And we would love to hear those kinds of requests. So the answer is no, but there's no specific reason for that. It's just that we weren't in a situation yet where we needed that. So let us know if you think it adds value for your case.
Fantastic. So that's, I think, the end of our questions. If I've missed you, I'm sorry. You can just drop a repeat into the chat, but we don't have any more questions currently. Does anyone have anything else? I think that's it.
Thank you for having me. I appreciate it.
That's okay. Thank you so much, Bob. It's really great to hear about Weaviate. And oh, I'm sorry, we did miss a question. Artem, you had a question about exact matches. Do you want to just copy and paste it so I don't have to scroll the chat window too far? It's coming, I'm sure. Is it possible to score exact phrase matches higher than similar words provided by vector search?
Yes. And this is also, so you have multiple ways of doing this, right? So you can, in mixing the scalar search and the vector search. So yes, one strategy might be that you say, we're going to do a scalar search that says like, it must contain this specific keyword. And then we want to follow up with the vector search. Other strategies are possible as well. If there's something that you're looking at that you currently cannot do, then again, we would love to hear from you, because that's how we learn where we can improve Weaviate.
Fantastic. Okay, I think we're going to bring this to a close. So firstly, I'd really like to thank Bob for taking the time to speak to us. It sounds like a fascinating project. I'm sure some of us here are going to be digging into it and taking a closer look. So thank you, Bob. We've got a couple of other things here to look at. Let me just get rid of my windows. So our next talk on Haystack Live is going to be, the next one scheduled is going to be June 24th, where we have Paul who's going to be talking about the Tantive search engine. So we are exploring other things other than Solr and Elasticsearch these days. But we do also have a potential talk on June the 3rd from somebody about an e-commerce subject, but that's not confirmed yet, so I can't tell you much more about that at the moment. We are looking for speakers and we're looking for subjects. So please, if you have an idea for a talk or you know someone you can nag into giving one, get them to go to the Haystack website, that's haystackconf.com, and look on the right, and there is a submissions form there which will come through to us. In the meantime, we've also got Berlin Buzzwords. So Berlin Buzzwords, very popular conference with the themes of search, store, and scale. It's running online again this year. We know the team there very well, and we have a guest spot as Haystack is partnering with the conference. And we've got a couple of events. One of them is a repeat of our great search engine debate, where we've got Ansham Gupta for Solr, Josh Devins from Elastic, and Joe Christian Bergam from the Vespa team. And we're going to have a big debate about which search engine is best. And I'm sorry to exclude Weaviate and all the others, but it's always fun to have a go at the shootout, even though we all know that we all appreciate each other's efforts, and it's often horses for courses. Come and join that. But we've also got a Ask Me Anything session, as I mentioned, with Max Irwin and Dimitri Khan, and that will be on the subject of vector search. So perhaps you'll be interested in coming along to that. So do check out Berlin Buzzwords. The tickets are very cheap really this year, but it does cost a little bit, but it's great to support what is a fantastic event which we hope comes back to a physical event soon. So do jump in there, take a look. Come and join us on Relevant Slack if you haven't already. We hit the milestone of 1,500 people about a week or two ago, which is fantastic. That's 1,500 people all talking search and relevance. Jump in, we've got a vectors group, so let's get chatting in there. And if you're interested in our training, we have more classes coming up in July and August. Think like a relevance engineer for Elasticsearch and Solr in July, and then our learning to rank training in August. Tickets are on sale now, so do jump in there and have a look. So any other questions you've got on search and relevance, you know where to find us. We're Open Source Connections. And a last thank you again to Bob. And we will see you all back here on Haystack Live very soon. And the video for today's talk will be up on YouTube so you can share it with your colleagues. Thanks for coming, everybody. Bye-bye.